In this video, we're going to look at doing some analysis from videos, see how we can take a good recording of an object in motion and convert it into some data. We might want to analyze that data using Excel or MATLAB or different programs, and we need to be able to capture that. We might be able to watch it in real time and see in general what's happening, but how do we convert that into a nice plot? So we're going to use this program called Kinovea, which is a free download, and we're going to take a video that I've captured, and we're going to see how can we use this software to pull data that we can actually use. So I want to come over and I want to open up this video that pulls my video in, and we'll quickly watch the video. I've just taken a spring, I've put some masses on the spring, I have a dampener on it, and I've got a mark. This piece of tape, the purpose of it is to make it easier to track. If you have a good marker, something that differentiates what you're tracking from the background, then the software does a much better job at following it. Otherwise, you have to manually, frame by frame, relocate the center or the part you're tracking, and that can be quite time consuming. So now that we've seen the video, we want to trim it down to what particular section do we actually want to analyze. So as it's playing, I'm going to pause here because this is our equilibrium position. Notice it's really not oscillating back and forth any here. So we can make our measurements from several different ways. I'm going to put our coordinate system at equilibrium. We can let our coordinate system be from the floor, our origin be at the floor, or really anywhere, but I want it to be fairly close to equilibrium. So what we can do is we can go to image, we can select coordinate system origin, and we can put our crosshairs at, I want to use this bottom right corner as our reference point, and we'll talk about that more in a moment. But I'm going to click there, and that's going to be 0, 0. So any displacement from there is going to be measured in a displacement in the Y direction and a displacement in the X direction. Now, we haven't told it how far distances are yet. So you might have seen on the coordinates that had PX, it was just measuring basically how many pixels we had gone over or up. The software by default doesn't know what the distances are in this image. It doesn't know if this is something that's really, really tiny, something that's really, really large. Are we in feet, miles, meters, what? So to calibrate it, we're going to draw a line. Click the line tool. We're going to draw a line on something that is a known length. We also want to make sure that that object is in the depth of the video that our motion occurs. If we trace something back here on the board, then this distance, let's say from here to here in the background, is not going to be the same distance in the foreground. For example, notice this leg and this leg, if we measured from here to here and here to here, the line segment we draw would be two different lengths, but those legs are actually the same size. That's just because of the depth. So we want to draw a line on our tape. Once we draw a line on there, we right click and we want to calibrate it. That tape is 2-inch wide tape. So now we have an origin and we have a reference to let us know how big that distance is. So now we're about ready to start, almost ready to start calibrating, or I'll say calibrating, tracking. So we put our origin, we put that in, but we want to continue, we want to trim our video. So I actually want to start the video at the peak, right when the spring starts. So here is about the moment I'll let it go. So to trim everything before that, I can click this left bracket, and that cuts everything before that. I can let it play, and once it gets to the point where it's almost not oscillating or gets close to the point that I stop it, then we can pause the video and we can click the right bracket and that will end it. That's good enough there. So click the right bracket. Now notice these arrows are around the segment that we're wanting to analyze. If I mash play, it only is going to play that particular part of the motion. Okay, so we want to track a specific point. If we just take our marker and we put our marker right in the middle of the tape, we have a fair amount of tolerance. If we're just tracking the tape in general, if it tracks the top for a while or tracks the bottom for a while, there is potential 2-inch or we'll say plus or minus 1-inch tolerance in there. And as a percent of the distance it's traveling, that's fairly significant. So let's pick a more precise location. I'm going to click this bottom right corner and we're going to try to follow it. So I click there, notice it puts a frame here that's referencing our key image. And then if I right click here, then we can track our path. Puts a box around it and that kind of narrows down where the software is going to look for the point as it goes forward. If we mash the right arrow, then it's going to manually go frame by frame. Notice it says position here, and that's basically what frame we're on. So if we mash forward, it's trying to follow it, or it's progressing. Notice our marker is getting off a little bit, so I'm going to move the marker down to the right corner. And then, oops, it got off. And it's best to correct that as it's happening. I'm letting it go forward. And it's following it pretty well. If it starts to get off, then I just drag the marker down to the corner and then I let it keep playing. Now, if it looks like the marker is following the object pretty well, there it got off. There it got off. We can let the software automatically follow it. This adjusts the play rate. I would like to slow the play rate down. And if I mash play, then it's going to automatically trace for me. If it gets off, I would just need to pause it and then make some corrections. So I'm letting it play. It's following that corner pretty well. Oops, notice it got off. So I want to go back. I'm just clicking my back arrow. And I'm going to go back before where it got off, and I'm going to right click, and I want to delete the path after this point. So notice this highlighted part, that's where it has been. So I delete it after that. So now we can start following it again. I'm going to use my arrow for a moment to try to keep it on there. And once it starts staying on the corner again pretty well, then I'm going to let it do it automatically again. If it gets off, we'll just pause it. We'll back up. We'll delete the path after we find a frame where everything behind that is good, and then we'll restart it. So it's staying on it pretty well. It's not moving up and down a whole lot right now. Since it's staying on it pretty well, we could speed up how fast it's going if we wanted to. You may say, hey, my marker is not on the right corner anymore, but it is on the bottom of the tape. And what we're going to evaluate is the height. We're not worried about the horizontal displacement. We're just looking at the vertical displacement. So as long as our marker is on the bottom of the tape, that's the main thing we're interested in. If we play, then it's going to show us what it has captured, where our marker is during different points of the video. And we can watch it to make sure that our marker is staying where we want it to. Now, if we pause and right click on here, we can configure, well, what is it that we're wanting from this path? Well, we want a distance. We're wanting some distances. And then when you do that, you might see this 125.94 inches. You say, well, the origin was right around here. That's not 125, 126 inches from the origin. No, what it's actually giving you right now is the total distance that point has traveled. Now, that's probably not what we are wanting right now, but when we select our data, that's not what's going to export. Now, if we just exported it right now, then it would give us the X and Y position as compared to the frame. Well, this is not recorded at 1 frame per second, so that's not really what we want. We want the position versus time, not the position versus frame. So there are different tools. If we go into option and do preferences, we can select how our time marker is formatted. I've actually already changed this. By default, it would be frame number. I've already changed it to total milliseconds. So now that we've traced our point, we have our coordinate system, our measuring, our calibration mark on there, and we've adjusted things to the correct units. Then we can export this, go to File and Export. We can export this to Excel. It's currently doing it as an XML file. We may want to change that later to Excel. Earlier, I had done this and called it Spring Example, so I'm just going to replace that. And then we can go to Excel and we can open that data. Notice it gives us a spreadsheet, that gives us a table, it gives us the horizontal and vertical component at various times. Remember, we set our origin about at equilibrium, but we started tracking it when we pulled it up. So notice our Y value starts at 7.5 and it starts going down because, and I just realized, y'all can't see that screen. So let me change what y'all are seeing. So, okay, hopefully you're seeing Excel now. So when you get into Excel, here's your table, your horizontal, vertical positions, and your time in milliseconds. Let's convert the time into seconds. So if we take milliseconds, we can divide that by 1,000. We'll drag this through all of these. We didn't record this for 21,000 seconds. We recorded it for 21 seconds, not 21,000, but just 21. We pulled it to a peak. So our peak was 7.5 at one time was 0, and then it started going down. So let's just insert a scatter diagram real quickly just to make sure that the data we captured is really what we think we were capturing. There's nothing like quote unquote capturing data and then you get to the end and you're like, that's not what I was trying to accomplish. My software didn't interpret things the way I thought it was interpreting it. So our X values, those are our times. Our Y values, those are going to be our vertical positions. And remember, we set our vertical distances to be measured from equilibrium, not from the floor. So now if we look at this graph, go back up. Notice we have a nice sine wave that's going down. Our equilibrium, we did a pretty good job of setting our origin. Notice our x-axis is maybe not exactly at equilibrium, but it's really close. So we have a peak around 7, then we go down almost to -7, and we oscillate back and forth. So it looks like we did capture the data that we were actually after.